everyone. Oh, that's a bit. Can everyone hear me okay? Yep, cool stuff. My name's Keith Burns. I work at Cisco Systems and work on the group-based policy project. Along with my teammates, we are in February this year, started working on integrating Neutron with group-based policy. So a little bit of history around group-based policy. We've been an OpenDaylight project since the Helium release. And for the Lithium release, we started to focus on, last November, we integrated with our kind of sister project in OpenStack, the OpenStack group-based policy project, and we completed that API integration. Then we started talking to the service function chaining team about doing a proof of concept for integration and got that underway. Then in February, we were approached and said, hey, it would be really cool if you're doing SFC, why not have a look at doing Neutron? It never really occurred to us. So group-based policy, the original use case that we're looking for is how do we simplify the way that applications interact with the network by using policy? So the whole intent, declarative, what you want, not how to do it type thing. And I was a bit curious about why would one want to do that? And it turns out that there's actually a really interesting use case when you start to integrate these two things and you want to do network function virtualization or NFV. So that's our primary use case and the direction that we're going for the integration. So I thought today we'll present a bit about what we've done with the Neutron integration. So this chap is called Mike DeVolkin. You know, he's a lovely guy. He's the father of what we're doing in group-based policy in OpenDaylight. He's been involved in policy for over 20 years. Now, he's been doing this since his days at Trimetra. You know, he was the inventor, or one of the primary developers for the Alcatel 5620 platform. He's worked at ONI, ObjectMart, Vertel, and then he went to Cisco and worked on the UCS manager, and it was a very model-driven intent framework. And then he became the chief science officer for Inseme, where he implemented a policy model. And then he's now moved and wanted to have policy in open source. Right? And there's been other open source projects that are focused on policy, but he wanted to take his 20-odd years of experience and put that into open source. And so there's an OpenStack project for group-based policy. There's obviously OpenDaylight for group-based policy, and Open vSwitch, amongst other things that are kind of evolving. So this dude doesn't get anywhere near enough credits for the work that he's done. He's an absolute genius. He's had a profound impact on my life personally. So I always try and make sure that he gets the credit that he's due. So that being said, so today what I wanted to do was walk through a tutorial. Now, I kind of screwed up. I tried to upload an OVA yesterday that's about 10 gigs. The idea being that you could all get it on a USB stick, and maybe we'll get there. But the idea is you import the OVA and it creates 3 VMs. Now, the 3 VMs that it creates are a DevStack control node, which also doubles as a compute node, a DevStack compute node, so we can do distributed instances, and then we have an Ubuntu instance as a very simple router. And I just want to make sure we're very clear, that's not doing any Neutron routing at all. That's purely to say that we have an enclosed system, all the routing is done in OpenDaylight, and we simply use that as a way to say, hey, I can get to www.opendaylight.org, right? So that's all that's doing. Now this chap, who actually happens to be in the room up the top right, is a chap by the name of Flavio Fernandez, and there he is kind of smirking in the corner. So Flavio works on the OVSDB project. So OVSDB has, as a part of its project, a thing called NetVert, and NetVert has done Neutron integration since hydrogen. So they're the pros. So when we decided to do this, we leveraged heavily not only Flavio's expertise and Sam Haig and a few other folks while they're in the midst of their own incredible kind of changes they've been making to their project, but also one thing we leveraged heavily was Flavio's Vagrant DevStack environment. So I have links to that. I have still got to work with Flavio on how I can bring mine back into the fold. I had problems merging my version of his DevStack environment, so I just put it up on GitHub, but it has full attribution from Flavio, so he saved us a bucket load of time. And so as many of you who may have worked with DevStack before, it can sometimes be a little temperamental, maybe. So Flavio helped a heck of a lot to get that very stable. So in terms of the tutorial, you get these 3 VMs, they all run in VirtualBox, so you'd import the OVA, it'd spin up the VMs, And then we run OpenDaylight natively on, say, your laptop, if that's where you're going to run it. So we'd expect Java 1.7 JDK. If you wanted to use our Vagrant version of this demo, you'd need Vagrant 1.7, and obviously Git to pull it down. And that's the link to our wiki, which has pointers to the GitHub repos. And there's also a GBP SFC demo up there as well. So here's some links for that, right? So again, the link to our wiki and how to get into the pre-made VMs, right? So it is, as I said, it's leveraging Flavio's Vagrant environment, but once I export it, you still use the Vagrant user ID. So in terms of concepts, I thought I'd go a little bit over group-based policy at a very high kind of philosophical level about what we're trying to achieve and how we're getting there. So when we think about policy or intent or whatever it is that you want to call it, right? Declarative type interfaces or declarative systems. I think of it, or we think of it in terms of policy surfaces, right? So you have, on the top surface, you have the expression of that intent, right? Whether it be via API or a mapping, it's how you interact with the system. And the next surface is the operational constraints, right? You want to be able to say, this is what you're allowed to do. So you don't have to bother the developer, for argument's sake, which is where we originally started with this, with those kinds of details. And you still have some control over the infrastructure. Then the next part is the capabilities and state. And how we implement that in OpenDaylight is with things called renderers. So why is that important? Well, one of the fundamental principles around intent systems is that the core model should have no domain specifics in it. Now, that's fine, right? When you start to look at, well, we'll get into the model in a bit more detail. When you take the domain specifics out, how do you actually do things like networking? How do you do things with OpenFlow and do things with RESTconf and netconf? Well, what the model provides is these kind of hooks, and I'll show you in more detail when we get into each individual model. But we provide these hooks where the renderer can express its capabilities, and that's how you provide the domain specifics. And in that way, the core policy model stays non-domain specific. And that becomes very, very important when we start to think about things such as, a friend of mine, there's a few projects in the community, right? Not just OpenDaylight, but in a lot of other open source projects doing intent. And we all talk, and what is intent, right? What is policy? We have all these debates back and forth about what it really means. And this chap called David Bainbridge, who's the PTL of the NIC project, or Network Intent Composition, came up with this fantastic phrase, is that one person's concrete is another person's abstract. And that really typifies the whole debate around intent, right, and what it means. And I'll give you an example, right? So to a DNS server, the name of a host is an abstract. And when it converts that to an IP address, that's its concrete. But to a host, the IP address is an abstract until it ARPs for the MAC address, and then the MAC address is concrete. To an Ethernet switch, a MAC address is an abstract concept until it puts it into a CAM table and converts it into a port where it's going to egress, right? And then that's concrete. So you have this notion of different interfaces and different interdependencies, right? And that's where we're going. That's why it's so important that there's no domain specifics in the core model. So you can have these interdependencies, and I try and shy away from hierarchy because we shouldn't get so tied to hierarchy because people automatically leap to the OSI model. I think we should be a bit more flexible in how we evolve networking, but still, you can have these hierarchy of policy resolution loops, and that's why taking domain specifics out is very important. Are we 100% there yet? No, but that's our goal. It's a journey. The next really important part is governance. Right? And in terms of governance, it's providing instrumentation. Did you do what you said you were going to do? Or what's the state of the system? And how do you feed that back? Because if you don't provide that in terms of this complete engineering feedback loop, you end up providing errors back to the user, and they have to inject themselves again and start to say how to do things, and you sort of defeat the purpose of a full declarative type environment and system. So are we there yet? No. Are we going there? Absolutely. I think I kind of covered the hierarchy of things, so let's just go into a bit of terminology around the model itself. So these are some of the terms that we have in group-based policy. I'll go through each of these in a bit of detail. So an endpoint is the thing that wants to talk. It can be hosts, it can be VMs, it can be ports in the case of our neutron mapping. It could be containers. But fundamental to group-based policy, hence the name, is this notion of an endpoint group, or grouping of things, a grouping of similar things with similar requirements. And a contract is an agreement between these groups about the things they can talk about, which we call a subject, which is defined by what they are listening for, right, which we put into a classifier, and what they do when they hear that thing. So subjects, what can we talk about? Classifiers, how do I know when I've heard it? Action, what do I do when I hear it? And it's at that point that we actually start to inject the domain specifics. So for the renderer, we have to define the features which make up a subject, and we call that a subject feature definition. And so when you see in the contract subject feature definitions, that's the renderer expressing what it can do for a classifier and an action. And then you create specific instances of that to leverage in a policy. Now, they're the non-domain specific parts. But at the end of the day, we're doing SDN. The N stands for networking. So we have to have some kind of forwarding model. So as part of our forwarding model, which is separate, and I'll show you that in a bit, we have this notion of a layer 3 context. So all a layer 3 context is a namespace for layer 3 addresses. Think of it like a VPN or a VRF. Then we also have a bridge domain. The bridge domain is a layer 2 namespace, and it's the domain in which layer 2 traffic is allowed to pass. And then we separate out the flood domain, which is the area which you can do broadcasting. Now, why would you do that? Well, I would contend that VLANs, and I've been doing networking for 20-odd years, the software development thing kind of came really late. I'd contend that these two notions have been conflated for a long, long time, right? And when we think about VLANs, we call it the broadcast domain, which is true, but it's also a layer 2 transport domain. And there are some interesting things that we can do with the evolution of networking when we separate out the two things. So sometimes you want to have layer 2 transport, but not necessarily have, or can have, broadcasting capabilities. A case in point would be any kind of WAN that does NBMA, right? So we separate out these two things, it is a hierarchical relationship, and I'll get onto that in a bit. But that's the separation there. And it does sometimes cause a bit of confusion, but what it does is allow us to have flexibility to do some pretty interesting things as networks evolve. So now onto the core model. So it is fundamentally based on a multi-tenant ideal, right? So underneath the tenant, we have groups and contracts. So groups both consume and provide contracts. Right? So the idea is on either side of a contract, someone needs to consume the thing that someone else is providing. Underneath that, then we have the subjects. Rules give us some more granularity and encapsulation. Also gives us ordering, because ordering becomes quite important. And within the rule, we have the classifiers and actions that I talked about before. So within a rule, in order for a rule to fire, all classifiers must be true. You must have a complete match. And then all the actions are performed in order. Now, the clauses give us a little bit more flexibility. So ostensibly, the contract, subject, rules, classifiers are all to do in between groups, but sometimes you may want to have some granularity down to the endpoint level. There's some peculiarities around an endpoint that you may want to be able to express. And so then we can have some characteristics about those endpoints that we can call out as identifiers. And so we add that into a clause. And the clause allows us to say which subjects are in scope based on not only the endpoint group, but also the endpoint conditions themselves. Now, separate to that, we have the forwarding model. So again, still multi-tenant, but now we have endpoints that have this notion of network containment or a network container. So a network container, it consists of an instance of a network context of which the subnet relates to, which can be any one of these three things down the bottom. But they does have a hierarchical relationship in between them. Like a flood has a parent of a bridge has a parent of a layer 3 context. Now a subnet could technically belong to either a flood, a bridge, or a layer 3 context, but there's consequences when you do that. So if you connect a subnet to a bridge domain without connecting it to the flood domain, you lose broadcasting. You can't ARP. So for the basic IP stack, subnet typically has a parent of a flood context, which then has a parent of a bridge and a parent of a layer 3 context. But it's the inherent flexibility, right? It's not hardwired that a subnet must belong to just a flood. So then what's a contract? So if we have a group of things, then the contracts themselves have this notion of directionality, right? So you have a consumer and a provider. You have to have a group consuming the contract. You have to have someone providing the contract. And directionality is from the perspective of the provider of the contract. So when we say things like web, right, we match on TCP destination port, and the direction is in, right? So from the perspective of the web server, providing the contract web, destination port 80 into it, right? Packets destined for port 80 into the endpoint group are allowed, right? For argument's sake, though, on the client side, the reciprocal of that would be source port 80 going out from the web server, but you get that notion of directionality. So you're not just saying destination port 80 is in the contract, well then the client would be allowed to receive port 80 and you get an undesirable result. So you need to incorporate directionality into contracts. But that's the basic crux of it. The other thing is when we combine that then, let's take these same endpoints using these same contracts, right? So we have a web, traffic can go into the web server, the clients can SSH into the web servers, and the web servers are allowed to send back anything they want. In this example, right, you can configure it as you like, right? We still have the one contract, but when we add in the layer 3 context, remember I said they're like VRFs or VRFs, we now can segment the traffic. So the same policy, but you can create traffic segmentation. So for argument's sake, you could have a policy for your production, development, test, the same policy across all three, but the traffic would be segmented based on the forwarding model. And I actually have that as part of the demonstration. I'll show you 2 Neutron routers. All the clients are using the same web client policy. The policy doesn't change, but the traffic is segmented. So here's a little bit of overview of the architecture. So in OpenDaylight, there's the Neutron v2 API, it's provided in OpenStack by a plugin called Networking ODL. That talks to OpenDaylight via REST, but it talks to the Neutron Northbound project. So the Neutron Northbound project is responsible for accepting those Neutron messages. And it has a series of methods or interfaces that if you want to do Neutron in OpenDaylight, you have to implement those methods. So currently, OVSDB has been doing this the longest, right? From there, VTN also has an implementation of Neutron, and ours is the most recent. We've only been doing it since February. OpenDove also is there, but I'm not sure that they're going to migrate to the MD-SAL just yet. When I was speaking with Brian, he said it was okay not to mention him, but I kind of feel like I have to because like they've been there for ages too. And there potentially could be more, and that's the beautiful thing about this MD-SAL architecture in OpenDaylight, right, is that a northbound project can just simply implement an API provided by another project, and then we as sub-projects can then choose to implement those interfaces. So in terms of group-based policy then, I'll try and highlight the difference between conf and opper wherever I can. It's a really fundamental, important principle in OpenDaylight that people really need to get their heads around, is this notion that the data store really kind of has 2 parts, has a configuration side and an operational side, and you can kind of manage your project around these 2 things, the state of the network versus what you want the state of the network to be, kind of build as versus as built. And then we have the policy resolver. So from there, we have this OpenFlow overlay renderer, right? So currently it's predicated on OVS. And from there, we talk to service function chaining. So we have these 2 different things going on. We have the mapping of Neutron to group-based policy things. We have a renderer that can have capabilities, such as an actions like allow or chain. And so it's renderers then that talk to service function chaining. It's an action. And Ronaldo, who will be following me straight after this preso, is going to be talking more about the SFC side, so I definitely don't want to steal his thunder. In terms of the actual architecture within OpenDaylight, this is more of a takeaway slide so people can see that goes inters and goes outers. Without going too much into, I'll talk a little bit more about the OpenFlow overlay renderer and its subcomponents, but we leverage the data store heavily. Now, I don't want to speak for Sam and Flavio, right, who are the principals on the OVSDB project, but they've done a lot of work in this release to move from, and as have done a lot of other projects, to move from the AD-SAL platform to MD-SAL. And so along that way, there's the capability now to use OVSDB purely for accessing the OVSDB schema on the Open vSwitch instance. That's really helpful, and we've made a big move from going to leveraging inventory, where we get the OpenFlow switches and we have to parse down through the tree to find information, to now being able to get that information directly from OVSDB. So that was really helpful. So we leveraged the OVSDB topology data store quite a bit. And that turns out to be really important when you're implementing a Neutron mapping. So now onto the mapping itself. So in terms of the neutron, and I think of this as a DSL, or a domain-specific language. And it helps us kind of keep that cohesive architecture. So we think about, okay, so how do we keep whatever domain-specific language is coming in from the north from being directly dependent on any renderer, right? So we just want this domain-specific language to map into policy things. Therefore, any renderer just has to implement policy things without understanding the DSL. And that's how we scale, and you'll start seeing that in a later slide on the future of where we're taking group-based policy. So these are the things that we kind of, a taxonomy of things that we had to care about. Obviously, you have the VM. We double up a couple of boxes here because we leverage security group and security groups and their rules, and we use them in two different ways, and I'll show that in the breakout. But obviously, there's DHCP. Whenever you create a subnet, if you choose to use DHCP, it creates a DHCP server, which has a port. Routers, same deal. You create a router, but it doesn't really do much to you until you connect it to a network, and therefore it has a port. And then you have this relationship between ports belonging to networks and subnets belonging to networks. And again, everything we've done has been predicated on OVS. And when I think about OVS, I kind of think about it in three parts. There's if you're familiar with the command set from the command line of Open vSwitch, there's the VSCTL or VSCuddle command. So I think about VS a bit differently in terms of the interfaces that are presented as like a almost traditional switch, ports and bridges and interfaces on the ports. Then beneath that, you actually have the OpenFlow pipeline, so the OFCuddle. So you can have a look at how OpenFlow is used in various tables to impact what happens for the switching fabric and how packets actually traverse the Open vSwitch. And then underneath that is a data plane or DPCuddle. And I'll show some of those commands that's where you can actually see where packets are going in the kernel space. So the actual mapping itself. So ports, pretty straightforward. A port to us is an endpoint. Now, in terms of forwarding, because ports belong to network, a network in Neutron is a typical kind of Ethernet network. It has flooding and bridging type behaviors. So we have we tie a network to a flood domain and a bridge domain. Because of that hierarchy and the relationship, we also tie the bridge domain to a layer 3 context. So as a standalone network, it does have a flood domain and layer 3, a flood, a bridge, and a layer 3 context relationship for each individual network. And I'll show how that ties into routers later on. Subnet's a subnet. Now, DHCP is an interesting one. So when we started to look at the mapping of how we're actually going to implement, we leverage security groups heavily for endpoint groups. That's coming up next. But it turns out when you start to have infrastructure resources within a Neutron tenant, things like DHCP, we put that into an infrastructure group. So we create a security group for DHCP. We create not a security group, an endpoint group for DHCP. And we create an endpoint group for routers and those kinds of things. So they're more infrastructure groups. But the actual port on the network becomes an endpoint. And that's how the Nova instances, which we also treat as a port, can reach the DHCP server via policy. So we have a contract in between the individual endpoint groups made up of the security group and the DHCP infrastructure group. So in the security group itself, security group maps to an endpoint group. So when we map a security group to a port or a Nova instance, that's treated as an endpoint in an endpoint group. And then the rules within that security group become the rules in the contract. And then with the router, the port that the router connects to, the gateway port or router interface port, is an endpoint. That way the different endpoints in different groups can connect to each other. And we create a separate endpoint group with a contract between the other groups that need to leverage it that allows traffic to pass. And we also map the router to a layer 3 context. And this is where it becomes really interesting, is that's how we get this VRF network type separation. I'll show that a bit later on. So when a network gets built and it has a flood, a bridge, and a layer 3 context standalone, and we create a router and we connect the router to the network, its parent switches across to the router. So now the network's within that namespace. When we add other networks, we add it to the same namespace. So now all the networks connected to a Neutron router within their own namespace for layer 3. So now onto the tutorial. At this point, we're going to try something, because last time when I tried, we were working before on switching between apps. Life did not go so well. Okay, so I've already brought up OpenDaylight here. And so when you run Carafe, the features that you need are ODL group-based policy neutron mapper, the UI. I put all that extra stuff in just because it's handy. And then to see when you're actually done, you can log tail and look for the OpenFlow overlay renderer to be completely initialized. So we're up and running. If I'd got my act together, you all would have VMs that look like this. So we have basically you can type in, I'll put some better instructions up on the README file. But you type restack, it does a quicker stack. So, for instance, if you were to pull down every single repo, it can take up to like 40 minutes, depending on your network speed. If you run in offline mode, doing a complete unstack and stack, it can take 10, 12 minutes. And with restack, a friend of mine from Huawei, Yipeng Wu, helped us out, and it's a bit quicker. It doesn't shut down every single service, so it doesn't do a full unstack, full unstack and stack. And doing it that way takes about 5 minutes. But with these VMs, you type restack, then from here, we can just do step 1. Whoop. And so what this is going to do is create the security groups for us, add some security group rules. I'll go through what those rules are in a bit. I've got a diagram that shows that. It's going to create a network for me. It's going to create the subnet. We're not going to create a router just yet. And it's going to create 2 instances, 1 in each security group. So when that comes up, please work. It did it. There you go.
Just to point out, this is a 2-node setup?
Yes, the 2-node setup that I showed at the beginning. So the DevStack control node is also running as a compute node, and we have just a standalone compute node. So this is the contract that's and the security group rules that we're using. So we're creating a client security group and a web security group. So we're allowing the client to basically have IPv4 in and out. And we'll show that when we get to the routing and external routing part of the demo, how it can get to www.opendaylight.org. And then we're creating a bunch of web servers, right? So we're basically saying you're allowed to ingress port 80, and you can egress anything you want. And we could restrict that further if we wanted to. But what that looks like in terms of policy is when you think of a security group, to me, it's half a contract, but it's a full ACL, right? It's saying, from this perspective, what can come in and come out. Now, remember, a policy needs to have a provider and a consumer. So we created this any group, or EPG any, which forms the other side of the contract. So each of the colored, like the EPG client and EPG web, have their ACL-based security group rules, right? And then they provide that contract, and any consumes that contract. And that's how we can resolve policy. Now, this may change over time. We're always trying to evolve how we're doing things. But for now, this is how it works. And we can see that in the GUI when we get that far. So in terms of step 1 that I just fired up, we're creating a single network. We're having them in the same subnet, but in completely different endpoint groups and security groups. We've got them spread across 2 different OVSs. So primarily, we use an overlay network of VXLAN, and that's how we connect to 2 different OVSs. So if you were to look at Horizon, this would be what you'd see. Simple network, 2 VMs. In terms of the UX, as I showed in the previous diagram, we're pretty serious about this whole engineering feedback loop around policy resolution. So that's the front splash page that you get when you have a look at the group-based policy UX. It probably behooves me to kind of make a point. Is Dano still here, or did he have to split? Oh, Dano had to leave. So we started this in February, and we probably around April or May, we'll approach and say, hey, you guys don't have a GUI. It kind of sucks that you don't. It's complicated enough, which we're trying to simplify. We'd like to do a GUI. These chaps turned this GUI around, and it was that late in the game, actually, Deluxe had closed. Like, Deluxe is the UX project for OpenDaylight. It had gone through code freeze. It's an offset 0 project when they broke ground on it. And that caused them all sorts of interesting dramas, from moving from Deluxe-based to plugin-based. And so they did a really, really wonderful job, given that, A, we didn't really have a lot of time to explain to them what it is we exactly wanted, and B, all we could really do is dump the Yang schema. So if you have a look at the UX, it's very alpha, and that's our fault, not theirs. They've done a really wonderful job given the time constraints and the amount of availability that they had to us about what we wanted. But again, I'd encourage feedback, but we are going to iterate on this quite a bit. But that's the basis. So if you go into governance, right, did we do what we said we're going to do? This is what you see, right? So based on that, those two VMs, two instances in two different endpoint groups connected up, you'd see these contracts, right? And actually not exactly these, because this is a picture I took, I think yesterday. If we actually go into, is this going to work? Please be kind. Okay, something went bump in the night. No, there it is. Huzzah. Oops. Okay, let's just skip this bit for now. The only time it goes wrong is during the demo. There's two tenants. Let's have a look, because I must have cached everything. Yeah, this is from a previous run. Okay, so it's remembered everything. Yay, me. So here's the endpoint group. So you can see from here that there's a neutron group client, which represents the endpoint group for the clients that we'll be running. You have a DHCP group, like we mentioned. Here's the any group and the web server group. And with security groups, you always get the default group. You can't delete the default group. It keeps coming back like a bad smell. So since we're here, never work with children and small animals and live demos. So here's our topology from step 1. So actually I might as well, while we're here, fire off step 2. So we have two clients. And we'll actually pass some real live traffic here in a minute. Did I come back? Cool. So now in step 2, we're going to do the same thing again, but with a router this time. So we're creating a new network. We're going to add a client. This time it's in a completely different network domain. It's in the 20 subnet, but it's in the same client group. And we can spread those across different OVS instances. And we have another web server acting here, and again in the 20 subnet. And not only that, we can spread 10 and 20 interchangeably across the OVS instances. So when we have a look at this, you can see from Horizon that we have our web and client endpoints in their endpoint groups connected via a router. And now before I'm going to start going into a little bit of our flow rules and how they all work and dump some traffic so you can actually see how stuff's moving around. But you can actually, via the UX, get deep into how the renderer works in terms of the subject feature definitions. So here you can see that because it's OVS and it's predicated on OpenFlow, you can classify things via the ether type, the IP protocol, or layer 4. So that's the capabilities that it can express to policy based on OpenFlow matching. You can see that we can, in this case, we have a destination port range that we can do for source port, desk port, or source port range, desk port, or source port. And our action definitions you can choose from allow or chain, right? So you can actually change the allow rules to be chain rules. And because Neutron doesn't currently have service function chaining as part of the API, this is one way of doing that implementation of introducing service function chaining to Neutron. It's not something we've QA'd. They're two separate things at the moment, but it's just simply a matter of turning it on. So as we look at the renderer itself, so the renderer has a number of components. We had this notion of a policy manager. So the policy manager kicks off a number of different threads or classes. So the policy resolver takes all things that you express in terms of policy from configuration. So you put your tenant with all your contracts and endpoint groups into config. It takes that, validates it, as long as there's an endpoint, right, that's inside that endpoint group, otherwise there's not much point resolving policy, and there's active switches, then we can actually write flows down. So we can put switches into the ready state once an endpoint's on it and there's a resolved policy. Now, this turns out to be a really important thing, and it was a big change for us from helium to lithium, is this notion of a switch ready. For argument's sake, there's lots of projects that use OpenFlow, right? And as soon as you do in OVS, set controller blah, everyone just goes, well, that's me. Fantastic, I'm gonna start dumping flows down on it. And if you've got 3 things trying to do that, bad things happen very quickly. So we try and make sure that, hey, if you connect an endpoint to this switch, you really want us to write flows. So we have a bunch of necessary and complete conditions that must be met before we'll start writing flows and trying to take over the switch. But the matter of pipeline coexistence is a topic for this week. It's a very interesting topic. A few of us have got some ideas on it. No, it hasn't been solved yet. Yes, it needs to be. Because as we start to do more and more things together, in terms of service function chaining, OVSDB, NetVert, GBP, VTN, whoever else uses OpenFlow, we need to sort this out as a community. So it's either going to be a process, a best practice, or some form of, we're not sure. We still have to discuss it this week. There's a lot of good ideas around it. So the basic components of the OpenFlow overlay renderer. The interesting part here is the switch update task. So what we do is we have a multi-stage pipeline, which looks like this. We create the entire flow map for the network and then do deltas at the end of writing to the data store. So you don't actually, in these projects, write directly to the OpenFlow switch. You write to the OpenFlow plugins config data store. I express that I desire to have this configuration on the network, and it handles not only the compilation of the rules, but also using OpenFlow Java, the serialization of the OpenFlow messages to the switch itself. And then the feedback it gets from the switch is how we determine what happened, and that's in Opper. So that's the idea of conf data store, what do I want to have done on the network, and reading Opper, what actually happened. Right? So we don't really write directly to the switch, but we express this pipeline in the OpenFlow plugin conf, and that's also a very interesting way of perhaps approaching this whole multi-writer coexistence problem. So in terms of the OpenFlow overlay renderer pipeline, we have port security. That's table 0. Everyone has to write to table 0. It's part of the coexistence problem. From there, we have to map based on the traffic, is this, what source endpoint group does this belong to so I can enforce policy? Right, so based on the information that's within the packet, how can I tell what source EPG this belongs to? Now, when we also support NAT for floating IPs in Neutron, we have an ingress NAT mapper. Now, it turns out that it makes more sense when you're actually just switching the IP address in that NAT mapper to perform the same functions as the source mapper. So it's really a NAT and source EPG mapper. Then from there, they both converge on the destination mapper. Who do you want to talk to? Can I identify what group you are? And that way, once you've actually worked out what source EPG it's in, what destination EPG it's in, policy enforcement becomes purely about what groups can talk to what groups using what sort of traffic. And then similarly, when we want to get out of the switch, if we do have to do NAT again, we do have an egress mapper, and then we have the external mapper at the end simply just handles that egress from the switch. Turns out with service function chaining, we need to do a little bit more there as well, but again, that's another presentation. So here, did I actually do step 2? Yes, I did. So here you can see we have 4 clients. So go here. Come on, Burns. So let's just we'll pick this client. And why not this one? Sure. So I'm just using Cirrus here to keep things pretty lightweight, but you could probably do a much more whiz-bang demo if you imported a decent kind of, say, Ubuntu VM or Fedora VM. Okay, so the nomenclature here, I'm not sure if you can read the tab, but just for simplicity's sake, I name the VMs based on what network they're in, then what endpoint group they're in, and then just a atomic incremental counter, right? So this is in network 1, which is the 10 network. It belongs to the web group, so we're going to try and launch some web traffic, and then the next one will be consuming that traffic. So let's see, how did I do this? Ultra do. So I'm just going to use netcat. Oops. Nope. Okay, so that's just going to spew out traffic. So here's our client. And so we'll just curl that traffic. I'm going to set a maximum timeout to be 2 seconds. That way we can just get traffic going. I'll explain why in a sec. Yeah, how about we do this correctly? Okay, so we can see we're getting traffic stuff from 10.1.1.4. And so you see the timeout, I set a maximum timeout so that it keeps requesting it. The reason being is that, remember when I was talking about OVS, and I think of it in 3 different ways, right? The VS side, kind of the switching side you're used to, bridges, ports, that kind of thing. Then the OpenFlow side. When you look at the DP cuddle side, when you convert that OpenFlow pipeline, that series of matches and actions, and can distill it down to what they call a megaflow, that lives in the kernel space, and you look at that using DP cuddle commands. But those flows are really short-lived. They live for about 10 seconds. So in order to consistently see them, you've got to have traffic continually refreshing those flows. So hence, we'll do the curl, and I'll show you. So these are 10.1.1.4. I forget where I put that. Let's see if it's here. So we can have a look at the actual traffic. That must be over here. So here you can see in the data path, you can look at these commands yourself later on, but the key thing is it's going from port 3 to port 6. Which is directly in between these 2 tap points. Now, these 2 VMs are actually in separate networks. So we're implementing distributed virtual routing here, essentially. So even though you don't have to configure the Neutron router as anything special, we can go through the provisioning scripts, if you like. We're just creating a standard Neutron router. But because of the way that we do our OpenFlow pipeline, all the routing decisions are done locally. They're done based on ingress, right? So therefore, you can make all switching decisions locally to that OVS instance. So we're routing in between network 10 and network 20 on the one OVS, the one on the compute node, right? So if the other 20 you happen to live on the other compute node, which is really a control node as well, it would go over the VXLAN tunnel, and I can show you that. But the key thing I want to get across here is, by the nature of the pipeline, you get DVR for free. Did you guys want to go through? We can go through the table in a little bit more detail. Question? Nope. But we have some pretty simple scripts. So this notion of flow count, you can have a look at table 0. Oh, I keep forgetting which version of this script I'm doing. So here you can see the ingress flows in our table 0. So you'll notice that we use priorities quite a bit, and we use drop flows quite a bit. The idea being that we only allow things in that should be allowed in that we know about, and we leverage priorities. So if we're going to say we're going to make an ARP flow for this particular endpoint that we know about, it'll be at 1 priority, the number of ARP flows that we need. Then we have a drop flow at a lower priority. So we always make sure that only things that can get in do get in. Right, so there you have this hierarchy of drop flows for each of the types of traffic. It supports IPv6, but we don't have any IPv6 endpoints configured, but you see the implicit drop there for IPv6. If we were to have a look at the source mapper, we leverage and this is what I meant by it's implicitly, even though we call it the OpenFlow overlay renderer, it's OVS, it's bespoke OVS, because we leverage the Nicira registers inherent in OVS heavily. That's how we kind of track things like what endpoint group, like source endpoint group, destination endpoint group. Hey, Morris. The forwarding context, where do you belong to? In terms of flood domain, bridge domain, layer 3 context. So now we can match on those registers, right? And that's how we can maintain separation in the pipeline between tenants. So each time when I talk about a register saying this is the source endpoint group register and this is the destination endpoint group register, it's implied that it's tenant plus source endpoint group. And tenant plus destination endpoint group. We take those things as strings and we create an ordinal, which just gives us an integer, and we slam the integer in here. So you get a unique integer for each type of thing that you want to track. And a quick look at policy. So in terms of policy flows, now if I did, not sure how well this will work, we'll give it a go. Okay, so these are just the flows that are passing traffic. You can see based on the fact that we're doing a curl that we're capturing TCP destination port 80. And so one thing we do need to do, and I'll get into this in terms of things that we need to improve upon, is more the ability to, so we can map all these endpoint groups and tenants and forwarding domains into these ordinals. What we haven't done yet is be able to reverse engineer those ordinals back into their constituent parts, which is pretty straightforward. It's all in a map. We just need to write the code to do it. But that's what I'll get into in terms of our big press for Beryllium. So there we've demonstrated policy being implemented as well as distributed virtual routing. So what's next? Oh, while I was there, I'll just fire off step 3 so we don't have to wait. How am I tracking on time? I'm going to finish early. Wow. I just know I'm missing out on a heap of stuff, so I do apologize in advance. Did that reset? Cool. So the next thing we want to show you is the ability to do external networking. So we implemented SNAT, one-to-one mapping. I think DNAT's kind of a bit beyond us in this time frame. It's a bit of a big problem to kind of bite off. But we wanted to be able to support the ability to get to the internet, right? So we implemented SNAT, and we implemented external access. So when you implement, this is a really interesting journey. When you start to implement external, some really interesting problems come up. The first one is that the gateway address for this thing lives outside of the OpenStack neutron domain, right? In this instance, it's 253. So we've already done all our routing in terms of DVR type functionality in the pipeline. I'll demonstrate that we're doing NAT, we'll map a floating IP address to an instance. But the types of problems that you have is how you get to this thing that's outside your domain. So Martin, do you want to put your hand up? So that's Martin Sinal. He wrote some really cool code that basically leverages the horrible, despicable functionality that we all just go, no, that's the devil of packet in and packet out. It actually can be really, really useful. So what we do is once we identify that someone's configured an external network, right? We have our floating IPs, et cetera. We create a layer 3 endpoint just for this thing down here, the 253 address. And this endpoint, as a layer 3 endpoint, it has a field for a MAC address. So the first thing he does is he sets up a flow that allows for an ARP packet to go out and to listen for the packet to come back. And when the packet comes back, he sends it back up to the controller. So he sends out the ARP request for 253. As soon as he gets that packet in, he adds the MAC address to the layer 3 endpoint. Those flows go away, right? So we don't have any more packet out, packet in type stuff going on. There's minimal risk to a DOS attack based on that, because you've got to be really careful, right? One thing that people hate about packet in, packet out, it's processing up here when it should be packets in the data plane, right? So those flows go away, and then we put the flows in that handle stuff going to the router. And I'll show you that in the destination mapper. So let's have a quick look at that. So yeah, I'm not as good at scripting as the guys who do this for a living. So you'll just have to bear with me while I hand fist a way to kind of associate this thing. So we're going to associate this address, and Flavio, these addresses should look real familiar, mate, since it's pretty much your IP addressing scheme. We liked it so much we stuck with it. All right, so we're going to associate this floating IP address here. So now let's go back to, okay, yes, you proved your point. You can stop now. So let's connect into this one. And this is always a bit of a hold my beer and watch this moment, but hopefully it'll work. It's interesting. 9 times out of 10, this works just fine. All demos work just fine. You always think, well, I must be due for a failure. But, probability being what it is, it's always the same probability it's going to fail every time. Please work. Oh, I'm a muppet. I need interwebs. Yeah. I got off the interwebs so I didn't get things pop up and inappropriate conversations come up. Is it going to come up and ask me? There we are. What is it again? Sorry. So I don't know how that VM, hopefully there's nothing weird with that VM not having internet connectivity. Yeah, well. Let's just make sure, this thing can get to Google. Okay, it can. Please work. Oh, sod. Well, that's just annoying. Sorry, folks. This does work. Otherwise, I wouldn't be standing up here repetitively trying to do it. As Einstein said, or it's attributed to Einstein, I don't really think it's true that, definition of madness and all that kind of stuff. Okay, so. Let's have a look at. Yeah, it didn't pick up that flow, because it didn't, networking was balked. I'll tell you what I might do, just to prove a point. Since I'm blazing through this and we have bulks of time. Five minutes, I said, right? Cool. We'll try that again, because I'm darned if I'm not letting that work. So because I'm going to restart everything, I'll wait to run the fourth step. But the fourth step I want to show you is that within a tenant, we can actually create multiple routers. So what might that look like? So we follow the same process of associating your networks with the router, the normal neutron type command line stuff. And in Horizon, it looks like this. So you can see over here, we have our two routers, right? Connectivity in between network 3 and 4, which I would have just created, and connectivity in between networks 1 and 2, and this DR external for Dr. Martin, Dr. External. But policy doesn't change, right? So when you have a look at the policy and the contracts that are there, there's no policy change. You're leveraging exactly the same policy in terms of it's the same endpoint groups, client and web, that all want to talk using the same contracts. But it is another part of the GUI that Dano, and by the way, I think I just, Dano's gone. I only just found this the other day because it used to look a lot different. There was this whole weird gravity thing. You have to drag things around, and they changed it to this, which is much easier to read. We have two completely separate networking domains. The very root of it is the layer 3 context, right? So with the two routers, all these endpoints that are attached to each of these different subnets cannot see each other. They can't ping each other, but they've got exactly the same contracts. And that's really powerful. So think about you have a bunch of contracts that you know you need to implement in production. So you can take exactly the same contract. You don't even have to make a copy of it, right? Same contract, and create separate layer 3 contexts for, say, prod, test, and dev, right? You can create multiple tenants. One thing that we support is tenant inherency. So you can inherit things from a root tenant, right? So there's a lot of different things you can do in a DevOps type environment. And one thing you will notice, I'm curious no one's actually asked, is why are there orphaned layer 3 contexts? Well, you can see maybe by the names, net 1, net 3, net 4, and net 2. When we create the subnets and we associate them with the flood and bridge domains for networks, say network 2 is the closest one to me, before the router gets created, it has a parent layer 3 context called net2. So you have the full stack of relationships of parent-child for the network containment. But we switch that across to the router when we add the interface to the network, which is all done automatically. So let's just see. I don't think that's been 5 minutes. I'll come back to that. I'll just go through the rest of the slides, and I'll go through, and we can perhaps even look at some of the actual flows. But so what? So what's the point? There's a couple of points of why you do this. In terms of why would you take something that could potentially have its own policy and do it in OpenDaylight? Well, the first is we've got our 2 OpenStack instances, right? And so each of these can map into the OpenStack domain. But because we're taking policy, right, we're interpreting neutron things and we're mapping it into group-based policy things, we now have all this policy information in the data store. You can take other workloads like Docker containers, and I've done this and shown it works perfectly. You can take a Docker container and say, hey, I'm an endpoint in group web. And it's exactly the same policy. It's just another endpoint. The flow rules don't know that you're doing neutron, right? Remember that separation of like church and state. Separation of the domain-specific language mapped into policy and the separation of the renderers just implementing the policy objects. They don't know the difference. The renderer just says, oh, there's another endpoint. I'm going to make flows for it, just like it would for a Nova instance. So, and to the policy, it's just, well, you have an endpoint over here. It has a location on OpenFlow. It has a MAC. It has a layer 2 context, which is the namespace. I don't care. So that's the real powerful thing, right? And then in between them, now you can actually connect these containers and they can leverage the policy that the Neutron admin or OpenStack admin set up to connect their workloads. So you can connect all these different workloads in different environments by leveraging the one policy repository in OpenDaylight. So where might we go with this and where are we going with this? It's this notion of any domain-specific language mapped onto the model. If it makes sense to map that domain-specific language, and some may not, then if it can map to the model, then great. And then you can take any network renderer. And so some of the renderers and some of the domain specifics that we're interested in doing. So layer 3 VPN is a bit of a gimme. You could do a classifier that says match anything, right? But put it in this layer 3 context. And so when these endpoint groups, endpoints register with the endpoint group, and you have them register into a layer 3 context, you've got a layer 3 VPN by default. The interface, obviously, everything that we do in OpenDaylight, when you create a Yang model, it creates an API for you. So you can leverage the REST API directly to get at policy. And the other thing I've kind of been doing a little bit of work on recently with a chap called Mark Burgess, who wrote Promise Theory, is how do we map IoT into this world? It turns out to be a really interesting problem. One of the problems around IoT is, well, I don't want to get too off topic, but one of the problems is that you've got all these disparate sensors out there, and you have to pull it up into these big data mining or inventory farms. I just say Hadoop generically, right? But each of those Hadoop things has to somehow know where all these sensors are and what all the sensors do. And you get very domain-specific interactions. And it turns out the characteristics of these devices play very well also into promise theory, which is a lot of the I'd say it's fair to say that promise theory has influenced a lot of what we do in group-based policy, in that one of the predicates of promise theory is that all infrastructure is best effort at its core. It's a bitter pill to kind of swallow, but once you embrace this notion that infrastructure is best effort, then you have to have that feedback loop. You have to have that feedback loop that tells you what's really going on in the network so you can kind of heal and you code and you provision as if it's best effort. It's what you want. Because as soon as you get into the micro tack of how you want things to do, and it breaks and it's inherently fragile, it's really hard to solve. You have all this human intervention. So if you plan and prepare as if the infrastructure itself is best effort, you can have a far more flexible system, right, is our contention. And that's why this feedback loop is so important. And it turns out this is extremely important for IoT. The other interesting thing is, if we can provide all these disparate sensors ways of connecting into a consistent data store, like say OpenDaylight, or a consistent thing that can manage and smooth all these inconsistencies that they are inherent in these sensors, then these applications can consume that. So you have a provider-consumer relationship. These sensors provide a service the Hadoop cluster consumes it, and OpenDaylight can be a very reasonable pivot point. And then when you combine that with service function chaining, and I did promise Ronaldo I wasn't going to steal his thunder. He's got a really cool preso coming up next. I do encourage you to stay for it, right? Because I know I've kind of blazed really through this, but when you combine that with service function chaining, you can do some really cool stuff when it comes to NFV. The ability to kind of say, well, here's my policy. When you meet these sort of criteria, I'm just going to allow you. Or if you meet these criteria, I'm going to mirror you. Or if you meet these criteria, I need you to go through a chain. And this becomes an extremely powerful combination. And because it's tied to the renderer, any domain-specific thing that can map to policy can now leverage service function chaining. So what does that mean for Beryllium and stable lithium? First of all, bugs. We're really, really focused on stable lithium. So as I said, we've only been around since Helium. And this chap called Rob Adams, he wrote group-based policy pretty much single-handedly with Thomas Buckman's help, but Rob did a lot of work, right? In our first release in Helium. Right? It was a monumental effort. And now we've done a whole lot of work in adding things like neutron and service function chaining, and it's our first real release where we've gone and said, well, now we've actually got something there that people might consume. We really need to start focusing on this whole life cycle of stable lithium. We were always focused on, well, helium's done, let's move on to lithium. Then we'll move on to beryllium. It's like, well, not so fast, Tiger. You got to fix this stable lithium thing too. So we're really going to be focused on things like clustering support, persistence, reliability, scalability in the stable lithium branch. We're going to be spending a lot of time there. The next thing that we're going to be focused on is instrumentation. How do you know you did what you said you were going to do? That's a big gaping hole in our solution at the moment. We don't have any, apart from pulling information from the data store, some bespoke scripts, we really need a nice interface so people can have a look at, say, click on an endpoint group and see what it's connecting to, what sort of traffic's flowing through it. Click on a contract to get that information back. Get it down to the endpoint level. Have a look at the tenant. How's the tenant performing? Be able to have a look at the conf and opera data stores for OpenFlow if that's what you're using. Currently we have one renderer, so that's it. Is there any disparity there? How are these things performing? So instrumentation is very important just to give you feedback, and then we can actually start doing some really cool, smart things with it. Is anyone from Brocade in the room? Right, so I was chatting to Dave Meyer around machine learning and the whole idea of the K clustering and how we take machine learning to take network element information and learn, right? And what sort of information can we glean by using machine learning techniques? And so that's something that's, I'm not going to commit that we're going to get done in Beryllium, but it's really interesting, right? And remember, as I said, a lot of this is predicated on promise theory, that the underlying infrastructure is best effort. So how can you, if something's best effort, how can you take the instrumentation and learn from that what might happen, right? Whether it's Bayesian probability or K clusters or what have you. Machine learning is something that may play into this, but step one is to get the data itself, which we don't currently do. But I know Dave gave a presentation in Prague last week at IATF, and unfortunately I couldn't make it. I had to fly back. But very cool stuff that Dave Meyer and his team's doing at Brocade. Very, very cool. The next thing is more of an SDK-like environment. Now, we can only do what we can commit to, and obviously if people want to contribute to the project and commit resources, more than welcome. That'd be actually greatly appreciated. But one thing I did recognize is in going through this whole mapping of Neutron to group-based policy and also working with the SFC is there's a lot of really good information within the OpenFlow overlay renderer in terms of heuristics. One of the observations we had was that, so policy resolution is generic and it's central, but it's from the standpoint of the observer. And what I mean by that, it's a little bit like watching a boxing match from maybe 50 rows back. You can see both boxes, right? You can see everything. You can see the little movements and nuances, and you can make observations, right? It's very different than standing in the ring and getting punched in the face. So what we found was there's a big difference between how you do things from the standpoint of the observer and the standpoint of the participant. And a lot of the heuristics that are in the OpenFlow overlay are from the standpoint of the participant, and they're very generic things that had to be solved and they're done in the renderer. We want to pull those out. and make them available to everyone, right, who wants to write a renderer. So once we started looking at what things could we pull out and how can we make this a more generic, non-domain specific environment, we started to realize that what we're really kind of talking about, this is kind of the wrong term, but people kind of understand it, is an SDK-like environment. How can I very easily and simply, or as simple as possible, write a renderer for this environment? Because I'll acknowledge, it's kind of difficult. You really have to understand the model. We want to make those, we already have the bits from the standpoint of the observer done. I want to take the bits out of the renderer that are from the standpoint of the participant, so you have a much easier time to express your, whether it is, Lisp renderer or MPLS renderer or RESTconf renderer, and consume policy. And at the same time, how we learn a lot from doing this domain-specific infrastructure-based mapping. Group-based policy did kind of start of how do we take applications and make it easier for developers to consume the network without having the infrastructure folks continually involved, right? That's where we kind of started. And to do infrastructure, which is primarily what Neutron is, was a pretty big departure. We learned a lot, and that thinking around taking domain-specific languages and mapping to policy also led us to understanding how do we actually map these things in a safe way that we don't accidentally create dependencies between the north and the south. Because once you've done that, the policy resolution part doesn't have as much value, right? Not just in terms of our environment is what I mean there, right? So that SDK-like environment is something that we're going to be working on. How do we make this more of a consumable tool that other people can use, and ideally even have policy resolution just be sitting there that other projects could come and use from there just as a data store thing without having to write northbound mapper, without having to write a renderer. So if you think you can leverage some of the things that policy resolution can give you, you should be able to consume it without actually having to deal with traffic. And the old canard, new and improved, right? So how can we take, are we gonna add new features? It's fourth for a reason. We moved pretty quick. We started this whole mapping thing in February, and we started service function chaining in November. And we ran through both in parallel. And for the longest time, it was Thomas and I. And then Martin and a guy called Tomasz came on board. And then a few other folks started helping out towards the end. And we had the mythical man, and sorry for the sexist term, but it's what it's known as the mythical man month problem, where we had all these people coming in who want to help. It's like, I'm already working 18-hour days, dude. I don't have time to kind of help you out with this. So now I think we've got in a place where we have a core group of folks who understand, but I really want to focus our team on fixing the bugs, making it more bulletproof. We've done the C part of CRUD, now we need to do the UD part really well. Making sure we support clustered environment, persistence, the instrumentation that's so important. So you know what you said you're going to do. We have this whole capability in terms of being able to now do some interesting things around machine learning, create the SDK environment so people can come and play, because we really, really want you to. And we're going to try and sex it up a bit with some new and improved features and get us to this. So I'd say, quite frankly, the expression of intent, cool, we're there. Capabilities and state, yes, we're there. Operational constraints, nope. Governance, yeah, kinda, but nowhere near the instrumentation that we should have. So that's going to be the focus, is completing this loop. Now let's see if my demo is actually working now. Okay, so we have restacked. Bring up this. Any questions while this fires up? No idea, man. I guess so. Why don't we just go with yes? Thanks, Casey. So Casey's been amazingly patient with me as I was really late getting this OVA up. Okay, we still got the Googles. Oh, that's what I didn't do before. Well, if you thought before was a hold my beer and watch this moment, how about that? Takes a long time. So what do you all think? Makes sense so far? Crickets? On the wrong? Yeah, I know. Thanks, Flavio. Thanks for not leaving the brother hanging. So while this, oh, it's come up. Cool. So these scripts will take a little bit to run. One thing I would point you towards, if I may. So we tried to revamp our wiki to make it less of a, so the wikis before were more about compliance with the OpenDaylight governance, where's your release plan, that kind of thing. It wasn't until, I worked with Brent and Madhu, who are the original chaps on OVSDB and Hydrogen, and they put a lot of effort into kind of documenting things, so one of the best wikis around there. So when I had a look at our wiki and where it had evolved or devolved to, decided to kind of try and think about it in terms of the constituents, like who would want to consume this. So it's very much a work in progress, but decided to bite the bullet and just go there anyway. So obviously always welcome any feedbacks, but we're trying to have events, what are we up to, links to various presentations, saying that news and events, so demos are now available for download. So if we go here, you can see we have a couple of different demo environments. So these are up on GitHub. So this particular one, oh, look, told you, Flavio. Not at all, man. You're a star. You really got me. And not just that, just any questions we had, like, hey, dude, why aren't I seeing router CRUD from the API? There's a reason for that. We spent 3 days on Wireshark trying to work out why that was. So, you were great help. You guys were awesome. It is a great community. So you can download this demo. This doesn't include the third VM for doing the lightweight router or routing once you actually get out of Neutron, which we can add, and always welcome any feedback. Here's the GBP SFC demo, where you can get it, and we have 3 demos in there currently, but it's always a work in progress as well. These things all evolve. Let's see where we're at. So can you speak up, man? I'm deaf.
I was just saying for the, what you're talking about for the planning for Beryllium, I think we're trying to have some sort of conference. Yeah.
Thanks, dude. Yeah. So actually, well, Thomas just basically said it, but for those who didn't hear, it's around release planning time. So what I was hoping to do here at the OpenDaylight Summit was to have an unconference session for group-based policy release planning, just to get ideas, what people would like to see, what they'd like to contribute, that kind of stuff. And we start to formalize the release plan. And it's not just gonna be here. So if you've got folks that's like, well, I can't do it, but someone back at the office would really like to be involved. We're going to have a couple of WebEx sessions as well in different times, different times of the day to suit different time zones. And then we'll go forth, right? The release plan is really important. It really sets the kind of direction. You've got to know what you're working on. So participating there is going to be pretty key. So yeah, I think the process is we just go hit a whiteboard somewhere and propose it. And if people are interested, they sign up for it. If they're not, they're not. And Brady, you're here too. Captain Brady from the SFC team. And so you planning on doing stuff, mate, or? You go for it. The floor is yours, my friend. Sure.
So what does this mean for the OpenDaylight OVSDB project, which also is trying to implement network virtualization?
Well, they're sitting right here, so you can ask them directly after. So, well, I'll give them the opportunity to answer. You can have the floor. I look at it very differently. I remember we started off with, did the OpenStack group-based policy, OpenDaylight group-based policy integration. We started doing service function chaining integration. And then someone said, well, if you combine this with Neutron, you could do some really cool things in NFV. And definitely not saying that the OVSDB guys, their solution precludes them from that, but I'm just saying mine's very focused towards that. The corollary is, I'm not focused on cloud scaling. We didn't even think about doing LBAS or firewall as a service, and I think you guys have, right? So slightly different foci, different approaches. I know I treat this like a DSL. I'll be the first to admit it. I look at the Neutron API, I look at Wireshark traces, I look at what the Neutron Northbound project gives me, and Martin, and implemented those, right? That's how we looked at it. Flavio's deep in the OpenStack community, right? And Sam as well, right? These guys are really a bridge there. Different foci, right? And I'll allow you guys, please, you can answer the question any way you want. There's not, replacement. Yeah. Well, they don't get much from us because we don't have a lot to offer. We're doing a little bit. But I jump on the OVSDB channel all the time and go, hey, Sam, you seen this? What's going on? Or Flavio, you guys seen this? What's going on? So, no, it's no impact, like Sam said. We work well together. If there's ways that we can, I don't know, it's an ongoing conversation. Some people in the community say that all these projects that are overlapping should consolidate. I personally disagree with that. I think there's room for everyone, and that's not just hippie talk. I honestly feel that there is room for everyone. You can go in different directions. Cloud scaling it's going to evolve. I'm not limiting OVSDB to cloud scaling, but it's definitely not a use case I'm tackling or intend to tackle or even have on the horizon, right? So it has its own set of problems that need to be addressed and it needs to be evolved and dealt with. And the cool thing is OpenDaylight has 3 active Neutron implementations, and we all get along well together. We all have the same problems. We all are willing to sit down and work them out. It's really cool. I'm really interested in how we work on OP-NFV. That's the open platform NFV. Really interesting. I'm only just starting to get involved. Thomas Buckman's only just started to get involved. Ronaldo's been involved for a long time, and Brady's been involved for a long time. ODL SFC's a established project in OP-NFV. Now, it's very, very cool time. There's a lot of good stuff going on. Yeah. Mm-hmm.
So what about group-based policy API itself that OpenStack kind of has defined? Like, how does that should be a straight mapping to these constructs that in OpenDaylight?
Yeah, so we've already done the. Oh, you dog! Look, trust me, it works, bugger it. Hang on, did that just work? I'm really sorry, folks. This was working. So the question was, how does this map to the OpenStack group-based policy project, or the API? Yeah. Oh, so there's an actual mapping. So the terms are slightly different, right? So it's the same model, right? It's Dvorkin's model. The OpenStack group-based policy implementation is limited by the things that Neutron can offer because it operated under the auspices of the Neutron project, right? So, there's conformance things there. Some of the terminology is different. OpenStack already has this notion of an endpoint, so you can't call things endpoints because endpoints already exist. They have things like policy targets. But the implementation itself was simply just a Python translation for the REST API, right? So groups, rules, all exactly the same. So that implementation was done like last November. But in terms of being able to do Neutron directly, right, and do infrastructure stuff for NFV, we need to implement Neutron. We can just take what OSGBP did, right? Does that answer your question?
Yeah, it does actually. So, yeah, I was assuming, yeah, it should be straight mapping for OpenStack API, group-based policy APIs to the OpenDaylight.
Yep. I'm wondering if I've got a firewall issue. Yeah, I turned it off before, but... Oh, you son of a gun. One thing you'll learn about me is I'm really stubborn. So I'm going to show you this working. Because Martin put a lot of work into this. And it's well worth it. Unfortunately, remember what I said about we do the C part really well, but not the U and D part too well? That's going to require some work. So let's just have a crack at this again. And I appreciate the patience. But any other questions while I'm up here dancing? Yep.
Just curious, how does this interact with the NIC project,
So the question was, how does this interact with the NIC project? Good question. So my understanding is that for NIC Lithium, they have the same notion that they have a model, right? It's a lot of similar concepts. It just is what it is. These things tend to converge, right? So they have a model that's very similar. They render to, and I mean that because they call it rendering, and it's not a pejorative. It's just different from our rendering, right? So they render to group-based policy, and they render to VTN, right? So they can translate their model to group-based policy things, and away they go. So that's a DSL as well. So in terms of intent APIs, if someone wanted to, if they had a different intent API, Nemo is a project. If they wanted to, they could map their intent API onto GBP things, and it's just a DSL to me. And they could leverage these things. Or if not, have at it. Right? So it was interesting. I had the opportunity to go to my first IETF meeting last week in Prague, bum gig, right? So one of our chaps from the Nemo IB project was chatting with us. And he was asking, how do I feel about a model for the IETF for policy? It's like, yeah, I think this would be a great thing, right? And it was interesting, the conversation came up around what's the best way to do this? And it's like, well, there clearly isn't a best way to do this. If there was, we would have all converged on that already, and we'd all be working on one project, right? So the fact that there is no one best way is the reason that there's different ways of different approaches. People think about this differently, right? So I think that's a really powerful thing, right? But in terms of being able to create a core model that could be standard, I think that'd be really important too, because you already know how I think about these things, non-domain specific, right? I think that's going to help us make the system much simpler. And I'd say that's been one of the criticisms of group-based policy is that it just seems so inherently complex. Part of that is we have a very rich data model. You take that data model, which is originally expressed in UML, you convert it to Yang, you automatically get this API, and now everyone can say, oh, the full model is an API. That's the only way I can interact with it, is to absorb this model with all its different features and stuff. And that causes people to kind of think it's way, way, way complicated. But when you start looking at it as simply groups of contracts about what you can talk about, how do you know you're talking about it, what do you do when you see it, it's not that complicated. But we need to be able to make it more consumable. That's on us, right? So we're trying to do a better job of that. The UX is a huge step forward for us too. Yeah, sorry, question. Yeah, Flavia. Oh, when we did the neutron mapping. So the question was, did we find something with the renderer that didn't give us what we needed, right, when doing this mapping? Absolutely, right? There's a few things. So, well, the first one is NAT, right? We hadn't had NAT in there, but there was some comments and breadcrumbs throughout the code when Rob wrote it around here's where you might put NAT. We chose to do it a little bit differently, but NAT's there now. The other thing, at the time it was expedient to have network domain as part of the endpoint group. And this is this conflation of domain specifics with the non-domain specific model. And so when you have that, it can be expedient at the time to make forwarding decisions on the endpoint group versus not, and that causes all sorts of problems. So unraveling that, which is what we had to do, took a lot of time and effort, but now it's done, right? We completely put network containment in the endpoint. And in fact, we're actually going to deprecate that part of the API where you can do network containment as part of the endpoint group, but at least that's proposed, unless someone yells at me and says, don't ever do that. But it's now part of the endpoint where I believe it belongs. So that was a big learning. We had some things with routing. So I wanted to do routing based on source, right? At the source, on ingress, rather than at the destination, which means you potentially are carting stuff across layer 2 VXLAN tunnels to get a routing decision when you really should be making that locally. And that also let us be able to do DVR, right? Like, it was, once you kind of sorted out the routing, I knocked over DVR in a weekend. Like, once we got the mapping right. The mapping took a while, but once the mapping was done, the rest just kind of played out. So that was kind of powerful. What other things? Thomas, what else did we have to kind of mess with? There was a lot of refactoring, but apart from that, so there was NAT. Well, yes, so external. That was a bit of a departure as well. Yeah, so the ability when you want to go, so external was part of the model, but we just never fleshed it out before. So we needed a way of basically, when you have a floating IP address, typically you go out BRX, as you know well, right? But others may not know. You've got BRInt, which is where the instances connect into, right? Your standard neutron ports, and BRX, how you get to the outside world. We didn't implement BRX. We just put it all in one big pipeline. And that was one of the cool bits of advice, Flavio gave us. It was like, I asked him, I said, oh, do I have to do BRX? He goes, no. I said, but isn't everyone going to get mad? He goes, no, I don't think they care as long as it works. So it's like, oh, cool. So I don't need to seek permission. That's awesome. So that was, it's always good getting advice from the experts. So the question was about the Nicira extensions. Do we need anything more? So whenever I get the very few opportunities to talk to Ben, it's not usually about that. So we have 8, right? I think we're going to need those steps. So we have 8. Would I like to see more? Yeah, because the difference between the Nicira registers and metadata is they're both within the pipeline, but you can actually access the registers in the data path, which you can't do with metadata, right? So that's a very powerful thing. I think it'd be difficult. I haven't looked into the OVS code for that side of things. I've been looking at it for more the NSH side of stuff. So I haven't dug into, you come across the registers, but haven't run through that code to see how easy it would be to extend it. Maybe there's a limitation on bit size somewhere that they've limited to 8. I think what we need to do is start to look at how we're leveraging the Nicira registers and say, okay, could I do that with metadata and free that register up? I'm not sure what the implications of that is going to be for the mega flows with coexistence, right? But my idea around coexistence was to leverage metadata to create namespaces. So you still got to sort out table 0, but if I could create a namespace for OVSDB, right, and a namespace for GBP and a namespace for SFC, et cetera, et cetera, et cetera, you sort out table 0. If you can sort that bit out, on ingress, you set the metadata for your project, and then you match on that metadata in every part of the pipeline. Remember how I said at the beginning we have this pattern where we calculate the flows holistically, then we write them? If you calculate the flows holistically, before you write them, if you want to do a delta, like what adds and what deletes, you only pull your metadata flows from the data store, and you only write your metadata flows to the data store. You get this notion of namespacing. Then how do you actually use different projects' namespaces in the one pipeline? it's easier when you're off switch because you can tunnel, but you can't tunnel to yourself. So I know there was some talk around, and you mentioned the idea of taps. I think that's definitely worth pursuing. No, it definitely is. I've been thinking about this as more of a linear pipeline type problem with recirculation, because once you go back out through, you're within someone else's namespace, so you just go straight through. But I don't know, man. Like, I hope that answers your question. All right. Something balked. All right. Look, I'm really sorry. I did this like 5 times yesterday. It all worked. Oh, you know why? Because I'm a numpty. I didn't start the controller. I was chatting. I'm a chatty Cathy. So why don't you guys tell me what's happening next for Neutron? Is there going to be a Neutron 3? Because we're at 2.0 now. Is Armando here? Is he coming to ODL? Oh, okay. So what's happening next? Sorry? Well, do you think port labels will ever take off in Neutron? Or be? Okay. So what we're talking about is, and I mentioned before, is that Neutron has a very strict list of things that it provides as part of its API, and it's difficult to kind of shoehorn service function chaining into it. So one of the ideas folks in the community had is if you could attach a label to a port, then that label could have its own semantic. So it's this whole notion, you hear it pop up in various open source projects, of the semanticless blob API, right? Attaching a label. The label doesn't have to, and by being semanticless, the label doesn't have to have any significance to anyone, excuse me, other than the reader. So for OVSDB, they could use it how they saw fit. For GBP, we could map that, say, to endpoint groups or to chaining. For SFC, actually it'd be difficult for SFC because they don't have a Neutron implementation, but we might be able to pass it through on their behalf. They could implement that as interpret that as a chain. I know that the L3 VPN folks were interested in the port label to be able to say what VPN an instance belonged to. So, there's an argument to be made. Again, I'm not as deep in the OpenStack community as these guys, so I don't know what the implications and general vibe is around that, but it's a solution. But I can see the, contention around the semanticless blob API, right? Yeah. Because I know when I was talking to the Docker guys, right, around that, they were very worried about the whole, it's a stepping stone, but once it's in, the semanticless blobs kind of hang around, and then what are you writing to anyway? So.
So then again, begs the question now, then that kind of indirectly saying we should be using OBSDB for neutron or
Well, if you want LBAS and firewall as a service,
then, but are there any plans to implement them as a group-based policy?
no, I haven't got any plans to do that. And I'm still getting my head around this L2 gateway thing, and yeah, I don't. There's a lot going on. And when do you have your session? At 3. Are you both doing it, Sam and Flavia? Okay, cool. So yeah, you can maybe go to that one as well, right? And get all different perspectives. I'm absolutely determined that this will. Oh, dude. I love you. Sorry? Yep. I can get to the Googles. I checked that. Here's the perfunctory removal of journals and snapshots. So just a quick poll. How many people here contribute to OpenDaylight or are interested in contributing to OpenDaylight? Either one. Cool. And how many people here, other than, if you already raised your hand, you don't have to put it up again. How many people here, actually, this will make it pretty obvious. How many people here have never run OpenDaylight before? Ever? You haven't? Okay, cool. That's pretty good. I thought there'd be people here for the first time. That's awesome. Yeah. So the question was, in terms of clustering, does GBP work out of the box? Are there any constraints, et cetera? So what I can tell you is that we work out of the box with the clustering data store. So far, that chap there who's very helpful, Thomas Buckman, about 1 yard from you, he's recently just run our clustering data store test. My understanding is currently, because we're so reliant on OpenFlow, the OpenFlow plugin doesn't support clustering, so there's some caveats there. But by and large, Thomas, the tests were successful, right? Apart from that caveat of the OpenFlow plugin?
Yeah, there's going to be some sessions on the OpenFlow plugin clustering. Moise is going to work with some others. But yeah, we have to work out how we're going to handle the plugin from an application, from a GPP application perspective, so that we make sure that the vSwitches, because there's, in terms of the data change notifications where the shard exists, we have to make sure that all the state gets to the right place so that we can have the right notifications to set things up, trigger the policy for resolution for the render, so that the render will input the policy and create flows based on the state changes and stuff. So if you have, we've run it right now where if you've got the shard leader for the policy is the same as the shard leader for the inventory, then everything just works, and you can stop it and start it again as long as that guy, the shard leader is still the same, then it all works. But we need to work with the overflow plugin so that, you know, like if the shard leader goes down, that the application works so that it propagates the correct state to the right owner, and so that we have all the notifications.
Is it because you're expecting a data change notification on a forward and not getting it? Is that why?
We've got, yeah, because inventory, we've got some maps, and we've got some, we get a notification from the inventory, but then the policy is on a shard. The leader is the same.
There are going to be some sessions on just figuring out what needs to be built in so that you can support application.
Yeah. Is it on Friday though? Unfortunately,
Thursday and Friday.
okay, so if it's Thursday, I can do it, but
There's
unfortunately,
one on Thursday.
if I can't make it, I'll make sure that someone that is there that will have the information.
Yeah, it's specifically for applications. What is missing in clustering, which is preventing your application to be deployed in clustering? So essentially that's what.
But isn't that the crux of the persistence project? The persistence project for providing applications, data persistence? Yeah, I've already done it.
Oh, you did, okay.
Yeah, that's how the routing VM works. Thanks, dude. Any other questions? Yeah. Do you want to address that? The question was around the issue around the, well, hang on. Is there an issue with clustering of OVSDB? Is that the question? Yeah, the other interesting thing about, say, take for argument's sake OVSDB and clustering and then take persistence, right? How much state do you want to persist? So if I'm, as group-based policy, leveraging policy stuff to create all these things in OVSDB, right? I'm talking about the OVSDB schema on the actual Open vSwitch via the OVSDB project. Can I derive that again on restart? Do I need that? Some things do, right? Obviously, right? They do, but it's kind of a balance. It's on a per project basis. Your goal should be, to me, is what things can I derive from things that I need to persist? So I think the unfortunate thing is I don't believe, Moise, is there a way to actually say, I don't need this persisted for this instance, right? Because so for OVSDB Netvert, they would want, I imagine, a whole lot of stuff persisted, right? Whereas I potentially would want to turn that off and derive it. Right. No, I understand that, right? So I would take something from my conf data store and push that into the OVSDB or even OpenFlow data store, and that's going to be persisted, but I may want to redo those things on restart. Are you able to turn them on and off, or is that on the roadmap? It's not persisted on the device. It's persisted in the data store, right? What exactly is this? Okay, so take for example if I have with one of the things we worked on the SFC project was a thing called SFC OVS. So when you define a service function forwarder, all you need to do is do a set manager to the OVSDB project. We see that as a thing, and then we can take when the SFF goes into scope, we can instantiate the bridge and the tunnel connections, those sorts of things. Then when the RSP comes into scope, we can do all the flows for the chaining, right? I may not want that information persisted. I may want to, based on whatever the failure domain was, look at the SFF information in the config data store and redo that, right? So I may not want the OVSDB information persisted in conf, even though that's how we provision things with OVSDB or, for that matter, OpenFlow, right? just for that project. Mm-hmm. No, I appreciate that. You can't do everything for everyone. I was just curious if it was come up or. But it'd be interesting to see how much of a big deal it would be. All right, please work this time. Then you can all run off to the next session. And thank you for your patience. Yes! And, well, I was going to do this just to show you that it's not contrived, but then why would I contrive that painful exercise? So sorry about that. That's what happens if you don't use Wi-Fi with VirtualBox. The internal networks get all upset. But yeah, so thank you very much for your patience. And by all means, if you want to get the OVA, there's some USB sticks down here. Come and grab one. You could always get the demo from the wiki. I think there's more being spun up. What's the ETA on those, you reckon, mate? But that's it. If there's no more questions, thanks very much. Enjoy your OpenDaylight Summit.